Alright guys, what we're looking at is section 3. This is on phase changes, so this is chapter 3, section 3 today. And what you guys are going to be looking at is, first of all, what is a phase change? So if I was to, let me just open up my toolbar here a little bit. Alright, so if I was to talk about basically what is a phase change, then I first need to know basically what is a phase. And so if I'm looking at what is a phase, what's another word for a phase? And so what I would think of is something that you guys learned last chapter, and that would be a state. And so what is a state? Pennsylvania, California, Ohio. But in terms of science, remember that there are 5 states of matter. And so those 5 states of matter, if you could give them to me in terms of increasing kinetic energy, which one has the lowest amount of kinetic energy, meaning it's got the lowest temperature? And you would say that it is Bose-Einstein condensate. And then next in line, I could say, I'll extend my arrow a little bit there, that going from Bose-Einstein condensate, increasing that kinetic energy, you're going to get to that solid stage. And then once you increase a little bit more, those solid particles that were vibrating in place are now going to be moving a little bit, but just kind of like flowing over top of each other. And so that'd be your liquid stage. And lastly, out of the 3 main ones that you guys know, would be the gaseous stage. So therefore that leaves us one more, which occurs at extremely high temperatures. Remember, it makes up 99% of the universe, and it's made up of 2 different types of ions, positively charged and negatively charged ions, which would be a plasma. Oops. There we go. Okay. So that is basically what we're looking at, is a phase change is going to go from, say, one to the next. And that would be considered a phase change. Or I could say that it's a solid directly to a gas, or a gas directly to a solid. We're actually not going to be looking at this right here because more or less Bose-Einstein condensate is kind of like a solid form. It's just in a more clumped kind of form. Alright, so there are 8 phase changes. In terms of these phase changes, most of you have heard of a majority of these, and so we'll go ahead and label them. We'll say number 1, number 2, number 3, number 4. Put the other ones over here. So number 5, 6, 7, and 8. And what I'm going to do is I'm going to change my pen color, and we're going to use red and blue. The red is going to indicate what is called exothermic, which we're going to talk about a little bit today. So actually, yeah, and we'll change that. We'll make the red endothermic. Let's see, eraser. Let's get rid of that. Okay, so we're going to say that the red is going to be endothermic. I guess I should have got rid of that. Okay. So the red is going to be endothermic. And so what I want you guys to think of is the 2 parts of this word. So we have thermic, which when you think of the word thermic, you're going to think of heat. And then you have endo, and endo means in or into. So an endothermic means that heat is going in. So this is going to be all those changes in state that are going from, say, let's just kind of add them up here. So we're going to start at solid to liquid to gas to plasma. So I put them in order of their increasing kinetic energy. So I know that if I'm going from basically left to right here, I know it's going to be an endothermic process. For example, solid to liquid. So solid to liquid would be considered melting. So melting is an endothermic process. And then if I went, say, from liquid to gas, and so liquid to gas, now I'm going to caution you because this is not what happens like outside on a hot sunny day if there's puddles. This is what happens if you were to, use a pot with water in it on the stove. And so that would be, we can add in boiling. I would accept boiling because that's what most of you would probably say. But the better word that I like is vaporization. So they mean the same exact thing, but vaporization is the more scientific term. That's what I would be looking for on tests. If you put boiling, I'd probably accept it, but I would just, give your paper a dirty look. It happens. All right, so that's solid to liquid and liquid to gas. But there's also one going from solid directly to a gas. And so I think I mentioned it. I believe it was Block 4 came up with it and the other day. So solid directly to a gas, the easy way to think about it is it starts with an S. So solid going to gas, that means that this also starts with an S, and it's called sublimation. And an example of sublimation, that was terrible. An example of sublimation would be dry ice. Dry ice is the best example. Most people understand and recognize what dry ice is. It's carbon dioxide that's kept at a very cold temperature, which causes it to be in its solid form. But whenever you expose it to, say, warmer air, dry ice actually does not convert into a liquid first. So it's not liquid CO2, but it goes directly into a gas. It goes into its gaseous form. And so that's sublimation. The last one that we're going to look at that's endothermic is going from a gas to a plasma. And since I said that plasmas are ionized gases, then that means that this is, ooh, man, I don't know what's going on today. Okay, so let's get rid of endothermic here. And I'll add it a little bit. Okay. So, ionization, which means that all of these are endothermic. I wanted to write this a little bit bigger. Okay. So now let's switch over to the blue pen, and these are going to be the ones that are exothermic. So I'll go ahead and add this at the bottom. And exothermic, once again, looking at the words, I see thermic, which means heat, and exo, if we're talking about it like in terms of like an exoskeleton, like for insects, exo means it's on the outside. So these are ones that the heat is going to go out of the system. So instead of going from at the top here from left to right, we're actually going to go right to left, meaning that we are decreasing in kinetic energy, or it's going to become colder, or they're going to have a lower amount of kinetic energy. So let's start easy. We'll go from liquid to solid just like we did before. So melting, then the reverse of melting is freezing. So we're going to put freezing in here. Okay. Then we'll keep them in order. So we'll go gas to liquid. So gas back to liquid. So that would be like the air going onto the outside container of your glass of water, and that would be condensation. And the reverse of sublimation, so now we're going from a gas back to a solid. This is one that a lot of you probably don't know or don't remember. And it starts with a D and ends in eposition. And the last one then, we went from gas to plasma to get ionization. So we're going to go from plasma back to gas, and we're going to deionize it. So deionization. Okay. So these are your 8 phase changes that we're going to be looking at. So you have melting, freezing, which are most common. Most people know those ones. Boiling or vaporization. So vaporization and condensation, sublimation and deposition, ionization and deionization, and once again, looking at which ones are endothermic and which ones are exothermic. All right. So I already mentioned that vaporization is what we want to use for when we're looking at that phase change from a liquid to a gas, but the question is, how do evaporation and vaporization differ? So we'll put on differ on this side, and there's going to be two reasons, and we're going to put on the same on this side. Okay, so we'll split this down the middle. So once again, evaporation occurs outside or on a tabletop, wherever it is where the substance, the liquid, is actually just resting there, and it might be at room temperature. But what happens to it is it then converts to a gas. So as we would say, like, let's say there's a little puddle chilling here, and the air starts to flow across the puddle. So as you see, like, air is going to be blowing up here, and what actually happens is it's going to start pulling up small tiny particles from the surface here, and that's what's actually causing the evaporation, is the movement of the air over those particles. So those particles on the surface gain enough energy that they're able to leave the surface. So the way that they are the same then is because vaporization then, if you had a pot, once again we talked about before, of boiling water. So there's the handle for the pot. It's just beautiful sketches and drawing. And so you have this on the pot, and then all of a sudden you see the steam rising. Let's say it's just a pot of water. And in doing so, then it's going from the liquid that's in the pot to a gas. And so that's the same. So they both go from liquid to a gas. What differs between them is how it actually does it. So once again, evaporation, you can see that the air is going to kind of flow across the surface of that puddle. But if you were to look at, say, a boiling pot of water, where do you see the bubbles come from? Yeah, they come from the bottom of the pot. And so if I'm thinking of like where I would see that phase change taking place, I would say that it actually occurs right at the bottom here. So they differ in the location. So we'll say location of phase change. And that's just one of these. So location of phase change. Okay. And so we would say that for evaporation, it's at the top, vaporization's at the bottom. The second thing I'm going to add on here is the temperature. And that's probably more of the obvious one. So evap is below boiling point, and vaporization is above boiling point. Okay. So moving on. The next two terms that we're going to look at here are called heat of fusion and heat of vaporization. And heat of fusion kind of makes sense to us, and we could say that, all right, for heat of fusion, I'm going to say that it's going to occur somewhere on this graph, and I'm going to explain this graph to you guys in a second. Heat of vaporization, on the other hand, has a term that you're more familiar with, this word of vaporization. And so where does vaporization occur? It occurs between the phases of a liquid and a gas. So as I'm looking at this, I would say that first of all on this is called, this is a temperature curve, and this is actually a temperature curve for a substance called naphthalene. And naphthalene, it's in your book, they use this exact same picture, so you'll be able to see this in there. But what happens is, in this picture, I can see that on the x-axis is time, and on the y-axis is the temperature. So we're saying as time is going on, what we're going to do is we're going to keep increasing the temperature in this container. We're going to see what happens when we keep adding heat to this. And so at point A here, I can see that from point A to point B, that as time goes on, my temperature is actually increasing. And so we're going to say that it's actually at its solid phase right on that slant. But then what you see is from B to C, look at this, it's completely flat. So time's still going on, we're still adding energy, but you'll see that the temperature is flatlined right at that point right there. So we'll say about like 68 degrees. So at like 68 degrees, the temperature doesn't change, but we're still adding energy. So the question is, where is that energy going? And the answer is based on this word right here, and it's called the heat of fusion. So the heat of fusion is the amount of energy required to change, and this is going to be a generic definition, to change a solid to a liquid. And it's a certain amount of solid to a liquid, so it's based on a quantity in terms of mass. And so that occurs right between B and C. So from B to C is where that heat of fusion would take place. And so I would say that heat of fusion takes place, in this example, this would be melting. Okay, so from B to C would be melting. So you'll notice then that as this phase change occurs here, the temperature doesn't change at all while the phase change is occurring, and that's like super important. But then going from C to D, what do you see that happens? So once we're at a solid, we then go through the process of melting, which means then that it is a liquid stage going from C to D, and you can see once it's into its liquid stage, the temperature will once again rise all the way up to about 140 degrees, and then we're hitting that point again where this flat line occurs. And so I can see that the temperature doesn't change from D to E, which means what's occurring there? Well, I would say that this is vaporization. And if I were you guys, I would probably just kind of draw this curve in your notes, and that way you kind of have it in there. You don't need the numbers on the side or anything, it's just the actual shape of it. And so then as long as you're labeling like this portion is a solid, liquid, and a gas, then you're in good shape. And so you can see then the gas is going to occur up there. I can see once again at this flat line between D and E, that would be where the heat of vaporization occurs, which is going to be the amount of energy required to change a liquid to a gas, and that occurs once again from D to E. Okay, and so that's what we're looking at with this one. Heat of vaporization, heat of fusion, it's basically more or less the energy that goes into it, and so that energy directly affects the temperature then as well. Alright, so just a little bit to kind of go through and see if we recognize what is the difference between all these different phase changes. You can see that I have some red arrows and some blue arrows in between each of these different phases. And so once again, if I was going from a gas directly to a plasma, once again I would say that that is, see if it'll drag it away, ionization. And if I'm going the opposite direction, deionization. Notice that the blue arrow is telling me that it's exothermic, meaning that we are losing energy, and the red arrow is endothermic. All right, so if I was going from a solid directly to a gas, remember that that is sublimation, very nice, and going gas back down to a solid, that was the tough one a lot of people don't remember, and that is deposition. Okay. Then going from a gas down to a liquid, that would be condensation, and then a liquid back up to a gas, that was that vaporization. Or if you had boiling, I'd be like, yeah, okay, but I'd prefer vaporization. All right, last thing, going from a solid to a liquid, that would be melting, and a liquid back down to a solid, that would be freezing. And that would be cold. Freezing. Freezing cold, going from a liquid back down to a solid. Okay, so there's just kind of to go through them and see how you guys do, because what's going to happen now is you're actually going to have a quiz, and your quiz is going to be very similar to what you see on the screen here. So, your substitute will pass that out to you, and all you're going to do on the next slide will be a word bank. So we could just pause the video on that slide, and that way you just have the word bank up there. You're going to fill in your answers on the quiz itself, turn that in, and once again, these are one of those quizzes that if needed we could do a second chance. We'll do second chances whenever I get back, and that way I can kind of keep track of it, because I'll be grading all the stuff probably once I return. Okay, so all you're going to need to know for this quiz is you're going to need to know the actual phase changes. So there'll be arrows. You're going to be looking at labeling them and just kind of filling in what your answers are. And you're also going to need to know which ones are endothermic and which ones are exothermic. So what I would highly recommend you guys doing, I guess I shouldn't rearrange that. is, let me see if I can grab a pen. Think about it in terms of, once again, the order. So remember that it is solid, liquid, gas, plasma. So remember, if you're going up that direction from solid to plasma, that would be endothermic, and if you're coming back down this way, then it would be exothermic. And that's the easiest way to remember it. So like slug P works for me. All right. So here is your word bank. So at this point, once again, you could pause the video, take time to kind of review your notes. Once you guys are ready, then just ask for one of the quizzes. When you're finished with your quiz, then turn it in directly to your substitute teacher. And once again, there's no cheating, no looking off of other people's papers. The only place that your eyes should actually go would be up here to look at the word bank if you need it, or just flip your quiz over because I put it on the back of your quiz as well. Okay, so these are up here in case you need it, but once again, it's a lot harder if you're looking up here because you can't really like cross them off as you use them. Okay, so on the back of your quiz, just flip it over, you'll see them there, or you are looking directly off of here. All right, that is section 3.